Hello everyone, I am a programmer at a company and this channel is Bit by Bit. Today we will solve the classic recursion problem, generate all parentheses. I will explain the idea, I will draw the recursion tree and then we will implement it. If we get a time, we will test it also. Yeah, let's go. So this problem, I have written it down here. Given n pairs of parentheses, write a function to generate all combination of parentheses. So what it means, n pairs means you have any number and can range from 1 to 15 here. Yeah, and can range from 1 to 15, and after that yeah, n is a pair, so let's just say yeah. So given n pair or so given n pairs means if you have n equal to 1, then you have a two spots. So two spots for what? Two spots for parenthesis. Parenthesis is this bracket, if no one knows or something. This we call as a parenthesis. This is a opening one and this is a closed one. Okay, so let's go it by example. The example which I have written here, n equal to 1. So n equal to 1, it means we have two spot. So first spot is this and second spot is this. So if we look here at the first spot, what we can put either the opening bracket or either the closing bracket. So it have a two spots. Okay, and likewise in the as because we have to generate all the combination of parameters, we don't have to limit while generating, because this would be the max subset, or you can say a power set of that permutation combination. Okay, so yeah, so if we look at the first position, we have two spots. First one is for opening bracket and second is for closing bracket. So we have two options here. So it means we have two permutations for the first spot. Likewise, we have two permutations for the second spot also. Okay, so now if we want to generate a total number of permutations for all those combinations, so in the PNC what happens, if you want to get a permutation of all the sequence, then what you do, you multiply them together. You multiply the permutation of an individual, so and you get the total number of permutations for the sequence. Okay, so let's say I am asking, let's remove this. I want to ask a simple question. If you have a three number, okay, if you have three spots, and you have only one choice, you have only one number, one, you have one to fill these spots. So how many total outcome will you have? So you can have only one, that would be 1, 1, 1, because you have only one choice to fill at every place. So you have one choice at the first level, you have at the one choice at the second and the third. You will multiply all these, you will get one. Okay, similarly, let's say you have a one, you have two options, 1 and 2. Okay, so you have two option here, two option here, two option here, total would be 6. And if you want to generate this, then it will be like this: 1, 1, 1, then 1, 1, 2, then 1, 2, 1, then so likewise you will have you will have 8 combination. Okay, here 8 combination here. So you got the idea of permutation here. So likewise this problem will also go on. We have to generate all the n pair of parentheses. If you have n equal to 1, then it means we have two spots. For two spots we have two permutations for the first spot and two permutations for the next spot. Total output will be 4. This is the math. Okay, this is the maths. Now how we will do it in code? Okay, let's look into it. So yeah, mm, in the code part, uh, we need to have some intuition here. Okay, so the intuition is, if you have to spot, okay, and you hide the first spot, let's say you are not looking at this spot, okay, then we have two spots for, when we have two permutation for here, it means we can fill either the opening bracket, either the closing bracket. Okay, now, so what we will do, the intuition is that we will first put the opening bracket at the one spot, okay, and then we will consider that, yeah, now we have the opening bracket at the first spot. Now we will think of think the option think of the option like for the second spot. Okay, likewise we will put, so what happened that time, it will be something like this. I have put down the closing bracket here, opening bracket here. Now I have two permutations for this. Okay, because the first spot have two choices. So likewise, what will be happen when I will put the closing bracket? So now we can see this 4, the answer, our answer 4 is distributed into two parts. Okay, the first one is like when we put on the opening bracket, the second one is we put on the closing bracket on the last spot. Then we have two options for the first answer and the two options for the second answer. So our 4 answer got distributed into 2. So here we have the idea of recursion, because in the recursion what we do distribution only, we do divides only. Okay, our answer can be divided. So the intuition of recursion is like coming from here. Okay, so it's all about intuition. So what we are doing, we are doing division of a problem. We have n equal to 1, like we have two spots. So what we did, we divided our problem was generate it for 2n. Okay, what we did, we said you generate for the last one, and okay, and multiply it with the first 2 into n minus 1. Okay, we said this. So this is a kind of idea of recursion. Okay, so let's do algorithmic coding. Okay, we will write the algorithm here. First, what we will have m. Okay, n equal to something. Okay, will input n. Third, what we have, we will go on the solution now. So what we will do, we need to have some containers to store our answer. So everybody is familiar of vector if we are using C++. So vector of string, let's say this is our answer. Okay, now what we will do, so yeah, what we can do, we have n, we have answer. Now we need to write a function. Okay, so that function, let's say we have generate parenthesis. can have generate parenthesis. Yeah, we can have this function. What it can have, it will have, okay, so yeah, before that I'm missing. We need to have a container where we will store our answer. Okay, so this is a container to store the list of all the answer, all the permutation we have generated. But now we know we need to have, we need to store our single answer somewhere in a container, in a variable. So we can have a string s. Okay, so initially this will be empty. Okay, as the recursion proceeded, it will get generated for like further onwards. Okay, so yeah, what we can do now, we will pass this. Yeah, this is our function generate parenthesis. Okay, uh, we have a main function here. Okay, we can skip this. We will focus on our main function, on the generate parenthesis function. It have a string. Okay, that string we have passed here, and what it will have, we don't need to write data type in algorithm. And what we can have n. Okay, n will like tell. Okay, so this is our current answer, and this is like this will help us to deduce our base case. Yeah, so let's discuss the base case also. I forgot this. Okay, so what's the base case? Base case is just when you are like trying to fill one position, and you have filled all the position. So let's say you have a string s equal to empty at the first case. Okay, then you filled it with an opening bracket, then you filled it with a closing bracket also, second opening bracket, then you filled it with again an opening bracket. So let's say then you filled it with again. Okay, now here the size of string is increasing. Okay, and this will help us to deduce our answer. So size on was 1 2 empty 1 2 3 4. Now here the size of string is 4. Okay, now let's say size of string, and let's say if our n was 2, then we have a string of 4 sides which have the opening bracket at every spot. So this is a valid answer for this. So let's, when n equal to something, and in the recursion as the string further develops, okay, then our base case would be when the string size would be double of n. Okay, so what should be the base case? If start size equal to 2 times n, yeah, then this we can return, we can store the answer. We can store the answer dot push back something, whatever as answer is, and we can return here. Okay, now let's back to algorithm. Okay, function generate, we can write the base case here. Okay, if copy this, we can paste it here. Now what will happen? Now we have a string as an empty starting. So what we will do, we will first attach the opening bracket, then we will attach the closing bracket, then we will call the same recursion again. Okay, because the size of s is increasing, so it will reach at the base case, and at the base case we are pushing the answer, we are returning it from here. Okay, so yeah, what we will do, we will add the opening bracket first. Okay, now we will call this function again. Now here is a one catch. Once we the once we have added the opening bracket, now again we have to put the closing bracket at the same spots. In the C++, when you put the opening bracket here, now if you want to put the closing bracket, you need to remove it. So you cannot do this, of course. This is not a valid function or valid operator, okay, for string. Okay, minus is not a, subtraction is not a valid operator for string. When it is valid operator, but it's not like it's most of the it it calculates on the character ASCII values, not on the basis of the last, yeah, matlab, it means, yeah, it calculates on the basis of ASCII value. It won't treat as a like array. Okay, the minus operator. So what we will do, we have s is actually an array of characters, or yeah, so we can do, we have a operation supported as a pop back. We can use this in C+. We can remove the, sorry, pop back will automatically remove the last character, and after that we can push the opening bracket here. We can, now here we can do this. Okay, now we will call this function again. So yeah, so this is a function. Now in the sixth spot you can return the answer. So yeah, this is the algorithm for generating all the parentheses. So we can do the try run. Sorry, yeah, for n equal to 1. I will make the recursion tree direct for the n equal to 1, so it would be easy to understand. So in the earlier we have empty string. Okay, now first we will put down the opening bracket. Okay, here we have put down the closing bracket. Okay, now okay, so yeah, you can see we have a string as empty here. We have a vector of string answer is somewhere. Okay, this is an array. Okay, now we have a string. We have n equal to 1. Okay, now we will go into inside the function. If s dot size equal to 2 into n, s dot size equal to not equal to 2, then we will go on this step. S plus equal to this, we have s plus equal to, now we will call this function again, generate parenthesis s comma n. So what will s have now? S will have this. Now n would be 2. Okay, so now we will call this function generate parenthesis for this input. Okay, now it will pop back. Now we will call this. Okay, so yeah, we will go, now this function is getting called. So our s, we will go into the again the top of function. If s dot size equal to 2 into n, s dot size is not equal to 2 into n. Okay, then we will go on further. Then it will s plus equal to this. So yeah, again one closing operator will be pushed. Now n equal to 1. Okay, so yeah, now again at this parameter we will call the generate parenthesis s plus equal to generate s comma n. So we will call this. Okay, So now again it will check if s dot size equal to 2 into n, yeah, s dot size equal to 2, n equal to 1, so 2 equal to 1 into 2, so now this answer will be pushed here. So yeah, now once it goes, it will push here and return. Okay, now what will happen, it will go here, it will pop this one. Okay, now it will pop this one and push the opening one, and n will be 1. Generate parenthesis will be called for this. It will again 1 2 equal to string size, then we will push this answer and return, and likewise it will go for all the answer. So likewise it will go for this part also, and we have got 2 answer here. Likewise we will get here also. One is this and other is this. Okay. First one we have put, sorry, first we have put this, so we will get this first and this. Yeah, we will get this one. Okay, so yeah, that's all. We have drawn the recursion tree. We can talk about time complexity. Time complexity is basically we are calling okay, so here we have function. Okay, inside of it we are calling 2 steps, and that is again of like that is have n as a parameter. Okay, so yeah, so for every till n, okay, till n, what we are doing, we are, you can think it like this, till n, okay, we have n equal to 2n, let's say. Okay, if we have n, okay, then we have 2n spots. Okay, and for all 2n spots we have 2 options. Okay, we are doing 2 steps, we are adding this, we are adding this. Okay, after it we are calling which is this part. Okay, so for all 2n spots we have 2 options. Okay, so here we get 2 option, so we will multiply 2 into 2 into n, exponent 2. Okay, or sorry, exponent 2 in, yeah, so it will be like this, 2 to power 2n. Okay, so in the big O, if you say, it will be of 2 to exponent n. Yeah. Likewise we can talk about space complexity for it. Space complexity, so space complexity is a max depth of this function. Okay, so we have a string, we have this string s now to store our temporary answer. So how far it can go? It can go max up to 2n, which is like number of strings. So like space content will be order of 2n. Yeah. So yeah. So yeah, that's all from my side. If you like this video, like, share and subscribe. If you want any specific topic, please comment. I can make videos on that first.